Okay. Now, first of all, before we go there, I've got to explain my understanding of the world and architecture. Now, very simply said that if I look at the world, it will be a system. And in that system, I can only generate wealth for the shareholder by either moving the profit that they make in the system or in the business against the assets that I use. Hence, we talk about the return on capital employed. So, if I'm a business person, that's how I make money. I want to know how much money I can make with as less possible assets that I've got to deploy in the business. Now, that is typically a very complex system. If we take the complex system and break it down into the next level, we are going to find what we call supply chains. Supply chains is simply we match a supplier to a customer. So you're just sitting in front, I'm going to stop talking to you now in the next few seconds, being academic. Okay, when we take a supply chain, we can break it down into what we call value chains. So typically a value chain is a start end in a particular domain that's owned by a specific entity. Also huge arguments in the academic world around what is a value chain, what is a supply chain. So hence you've got the value chain organization, and you've got the score organization, and they both want to create the same type of models. When we look at the value chain, we can take the value chain, we can just dissect that into end-to-end processes. We can take the end-to-end processes, we can dissect that into process flows. And when we take the process flows, we can dissect that into what we call activities, or steps, or tasks that constitutes the lowest level of dissection of the system. And they typically do something with objects. That's cool architecture talk, isn't it? An object. Okay, so they've got relationships with each other and they do things. So that is my conceptual understanding when I look at a system and try to understand how the system is going to work. We'll get back to that in a minute. I'm not going to go through the formal definitions, and there's a few number of graphs. What I'm going to explain now to you is that there's a world of physics involved with the architecture. Whether I work on a complex system level, whether I work on a server level, there are physics involved. Hence why I pulled my friend Isaac Newton and said, please come and explain something to me. When you work in the world of physics on a server level, that means a transformation of an activity that deals with little entities. There are a number, I'm not going to go through all the detail, but there are a number of fundamental concepts that describes the physics of a process. One of the most interesting ones is utilization. So when you build a process and you put people into that process and they execute the process, they are going to be utilized in terms of capacity. Now, very interesting, when you start to do the mathematical modeling, you will see that as your utilization of a server increases, your waiting time or your throughput time or your cycle time is going to exponentially grow. Very weird. So if I push that person from 90 to 95%, it might mean that my cycle time or my service time, my throughput time of that process is going to grow exponentially. Very interesting. Your boss is going to say to you, you know what, you've designed this new process, why are the people taking longer to do their work? Fundamental principle around, the physical principle around utilization. We've got things like Little's law, we've got queuing physics that says that, very interesting, if you start to introduce variety into the process, you are also again going to increase your queuing time or your cycle time of the work that you do in the process. Some very fundamental physics when you work with a process. When you start to work with a process flow, there are physics involved in terms of how do I deal with volatility in the process, how do I deal with variety in the process, and then how do I buffer all of those things. We've had a case of a client where they said, you know what, we're going to batch all our transactions, and that is going to enable us to get a higher throughput in the process. But there's a physical law that says as you increase your batch sizes, it's going to decrease your efficiency of the system. So when you deal with a server, there's physics involved. When you deal with a process flow, there's physics involved. And I'll explain to you why a little bit later on why these things are important. When we start to deal with complex chains, value chains, when we start to deal with supply chains and things around that, there are also physical laws involved around where you put safety stock. Okay? How again do you deal with the customer where in the chain to optimize variety in the process? What should be the safety stock levels in that process be? Because it can be inefficient, and what this will result in is that it will decrease your business performance. So I'm getting to a point here is that the business person wants to optimize his return on capital employed. He wants to make profit out of his assets. Use the architect, does all these little meta models, do all the process designs, do all the optimization stuff there, and that's what he wants. So what I'm trying to show you, there are physical laws involved. Now the most interesting one that I find in organizations, especially on the strategic level, when we talk about the business strategy, we talk about IT strategy, we talk about visions, common goals, where organizations are going, always comes back to this thing called the law of requisite variety that was designed by or defined by Mr. Ashby in 1956. Now basically what he said was, any organization can either move with its degrees of freedom, either can increase its scale or it can increase its variety. You can't do both at the same time. So what the Romans did there on the left-hand side, very interesting, how they managed to conquer the world was by making sure that their soldiers were making war on very standard operating procedures. They were not allowed to deviate from those standard operating procedures. Through very effective communication, they managed to control the world. Now, in the Gulf War 1991, the Americans did something very similar. What they did in there, they just put a huge amount of resource into the battlefield trying to win the war. When they went into the Afghanistan war, they discovered that their centralized effort didn't work very well, and they had to move to a more decentralized environment where they had smaller groups of soldiers, and these then went out on directives and they fought their wars with the Taliban. So the physics of a system says you cannot change both at the same time. Now, a very interesting thing to me, and I had a look about this, and I actually thought myself about the Facebook business, that it manages 150 million customers, and it allows people in that system to create their own worlds. So it allows you to create variety. If I want to put an advert to my Facebook profile, I can do that. If I want to tell people where I've been in the past year, I can do that. So it allows the customer to create its own world. It allows the customer to buy whatever he wants to buy. I want to offer variety to my customers. And there's some very prime examples in the press. If you now go through the press, some companies are saying to you can buy whatever you want to buy from a product and service side. But remember, the law of requisite variety says you can only change either one of those axes. So what you need to do then in a business or in a system is that you need to change your degree of freedom. That means you've got to create a particular capability in the organization that will allow you to move to the right side and change both of those axes. And I've walked around here now and I saw a lot of people talking about capabilities, strategy, visions, all of those type of things. But if you create as an architect that stuff, and you don't understand this, the probability of you being able to service your customer, the business in terms of what they want, is going to have a problem. And I'll show you some of the examples that creeps up. But this one always comes up when you start to create a strategic architecture and trying to understand what you need to do and not to do. Very interesting man. He wrote that about 60 years ago.